My name is Major Clifford White and I am the Australian Exchange Officer at Experimentation Division Fort Gordon, formerly known as the Battle Command Battle Lab. Today I'm about to present a recent experiment that we conducted with the medical community called Remote Combat Casualty Care on the Move. It was a proof of concept collaborative experiment between William Beaumont Medical Center, TATRIC, Texas A&M and Experimentation Division. The aim of the experiment was to investigate the combat medics and combat lifesaver success in conducting a medical procedure on the move when mentored by a doctor. Reducing the golden hour dramatically increases the survivability of a patient. By providing the medic at the point of a casualty the ability to be mentored by a doctor through an unfamiliar complex procedure should improve a casualty's survivability, thus leading to the concept of the experiment. This diagram gives an operational view of the capability. For example, a medic supporting an expeditionary force has a global communications capability to talk to a doctor via video and voice through a satellite network architecture. This next video describes the conduct of the experiment in more detail. To note, the British and Australian exchange officers that work at Experimentation Division designed, built and configured the network architecture that was used for the experiment, in contrast to the news article.
At 10, a new way to save soldiers' lives in the field, and it uses some cutting-edge technology grown right here in the Lone Star State. ABC 7's Daniel Marin is live with more. Daniel.
So right now this is a pilot project, and basically the way it works is they set up a camera so doctors here in the States can walk Army medics through life-saving procedures for soldiers, say, in Iraq or in Afghanistan. But as you're about to see, it's a whole lot more than that.
This is the scene soldiers prepare for but never really want to see: a soldier down. Though this is a Fort Bliss simulation, the intensity is very real and every second very important.
The victim is unconscious, not breathing, with the shot to the face.
This fake patient needs a tube in his throat to keep him breathing and keep him alive.
They're able to talk to us, they can see what we're doing here.
And in this moving emergency room, he's about to get that tube from his unit's medic and a doctor miles away at Beaumont Medical Center.
Let me know when you're ready. I can see you on video.
What I want you to do is make a cut in his neck right here.
The knife advances by pushing button number 1. It's just like a box cutter.
Roger.
The doctor walks the medic through the procedure with video technology developed at Texas A&M University. And without it,
It'd be a lot harder.
Basically, there's a satellite dish on top of the roof.
That satellite beams the video and audio from the field directly to the doctor's computer.
It's a flat satellite dish.
You may have noticed this soldier's accent. He's from Australia and his friend is from Great Britain. Alongside their Fort Bliss allies, they too are learning the new technology, because when that IED hits, everyone's blood bleeds red, no matter what country you're from.
It can be a multinational capability.
Excellent work, sir. You just saved this man's life.
Very impressive stuff. Again, everything that you saw was part of a test for a pilot project. It will be up to the U.S. military when and if they put it to use. Reporting live, Daniel Marin, ABC 7.
The concept of the experiment was very simple. A doctor located at William Beaumont Medical Center or Fort Sam Houston would talk a medic or combat lifesaver through a cryothyrotomy procedure. The medic was located in the back of the ambulance, who would have direct communications with the doctor using voice and video. Over 100 medics and combat lifesavers went through the scenarios in order to obtain statistical significance. This details the communication capabilities that were designed for the experiment. Two major design constraints was given to Experimentation Division. Firstly, total integration costs must be less than $100,000. Secondly, it must be non-obtrusive and not inhibit the medic's ability to conduct their work. The key communication technology for the experiment is a commercial KU satellite-on-the-move technology using RaySat's low-profile phased array antenna. AS encryption was used for all wide area network and wireless links. The video cameras are remotely controlled by the physician located at William Beaumont Medical Center. This diagram details the communications network architecture designed by Experimentation Division. Data is currently being analysed. The feedback from the medical community is very positive, who are very impressed with the communications capability designed for the experiment. They are currently debriefing DCDD in order to create their own on-the-move capability. This concludes this presentation, and more information about the experiment can be obtained from Experimentation Division, TATRIC or William Beaumont Medical Center.